Very much, Robert. Yeah, it's a real honor to introduce our very distinguished speaker today. Professor Pumain got her PhD in the École Normale Supérieure in 1980, and then had a long career at Paris, the Paris 1 University, the Panthéon-Sorbonne University. She has many distinctions. CNRS bronze medal. She is member of the Academia Europea. She is member of the corresponding member of the Austrian Academy of Sciences, the British Academy of Sciences. She won the Vautrin Lut Prize also in 2010, and also an advanced ESC grant, which also I see here on the screen, Geodivercity. She's written also several books, also and edited also a few books, and those are very interesting books also in relation to the talk later on in December on hierarchies. One is the hierarchy in natural and social systems. So it's worthwhile if you're interested in those topics, maybe also to look that up. So again, in summary, I'm very honored to have you today as a speaker, and we're looking forward to your talk. Thank you very much.
Thank you, Professor Dijkstra. Thank you very much for the invitation. I also feel honored, and I will try to tell you what we have done about scaling laws in urban systems, trying to insist on the topic which are more specifically urban, because I think that you are better trained than I am in mathematics and modeling, probably. So, when applied to cities, has a very number of meanings, and I recall here a few which may be more or less interdependent, but not completely. And observations about scale effects have for a long time been part of the science of geography in connection with other disciplines. So, of course, we think of cities at different scales, as here on this map of China, and the map of the city of Datong on the right side at a different scale. And so, obviously, the patterns are different when you look at cities within a territory, forming a system of cities, and at the spatial organization of one city inside. So since long, we have suggested that three major levels of observation could be distinguished when studying cities. The level of individuals, where they have different descriptors and freedom of action, but altogether they make something new emerge, which is a city that has properties that cannot be owned by the individuals composing it: centrality, function, morphology. So this is a very remarkable case of what is called in complex system dynamics a case of emergence, and a less known fact of emergence is at a higher scale, at the scale of cities within a larger territory. We observe hierarchical differentiation, functional diversity, spatial patterns that are part of the science of cities. And I won't explain in detail how the emerging properties are produced, but of course, from the many interactions that occur at different levels, and not only from bottom level to the strictly upper one, but it may cross different levels. So we have developed a theory of urban systems being societal adapters, which are characterized at each level by spatial and temporal characteristics that are really different. So there is not a continuum from the individual house until the largest cities, but the largest territories, but we have a kind of discontinuity first at city level, being a space where connections between different places that are visited each time in number there are 3 to be visited each day by each person, with low speed networks, where the speed has increased, multiplied by a factor 5 only since the last 2 centuries developing motorization. So many interactions each day, and this is enough to have built an entity where you almost always observe rather strong density, population density and price and activity density and price gradient from the center to the periphery, a fractal spatial organization together with a functional and zoning and social differentiation. So there is an organized pattern of a system at that level. And at the level of system of cities, the connections are looser, but maybe distant from one day traveling nowadays. And with using high-speed networks, the speed has been multiplied by 40 since 2 centuries. So it means a space-time contraction much stronger at that level of organization. Also, the interactions are less frequent. They give rise to the hierarchy of size, scaling that we will analyze more in detail between size and number of activities, and the functional and cultural geodiversity. So one striking feature regarding scale is this differentiation of city size in all national or continental territories according to this way of representing population and the number of cities, accumulated number of cities regarding their population threshold. And we have a continuum of city size that may expand over 4 orders of magnitude, between a few thousands to tens of millions inhabitants, and it is rather rare than in the real world. You get the same word for describing such different things in terms of size. And of course, in each part of the territory we analyze, the size of city is relative to the territories they are embedded in. We also have a specific spatial organization of those urban systems that at the scale of cities have been coined as regular for a long time with the schemes of Christaller, a German geographer, who explained the hierarchy of cities, starting from the diversity of services they were able to sell to the neighboring countryside and the smaller cities. And at the the level of the city, we also have regular patterns which are of the fractal type, and you can recognize them at very different level of density. You have those cities of Atlanta and Barcelona represented at the same cartographic scale, but they have a similar population and they occupy a footprint which is completely different and prevents Atlanta from having an efficient metro system as this one exists in Barcelona, as represented by Berto. I like this map realized about the distribution of settlement system in Neolithic time in the center of China, because you see how similar it is with the schema of Kristaller. And it is true that we have this spatial organization of cities persisting over a long period of time and keeping more or less the main relative size between cities over a very long period of time. Here, 2 centuries for Europe, 1 century for India. Circles are proportional to population size, but the main points of the system remain the same over time. So there is a kind of homothetic dilatation of the system. And we may wonder why.
Professor?
Yeah?
I've just had a request from one of the audience members to take the distance from the microphone, just slightly away from your face. I've had a request just to move the microphone.
Is it better to now?
Just to push the microphone slightly away from your face.
Away.
Yeah. I've just had a request from one of the audience.
Sorry.
Super. Yeah, it's perfect.
It's better. Okay, thank you. Well, and then you all know, being a specialist of complex systems, that a good explanation of this zip flow can be a very simple stochastic model of growth of the elements, which was invented by the French statistician Gebra in 1931. And but the problem with geographers and social scientists in general is that this type of explanation is frustrating, because among the hypotheses for getting a log normal distribution is that all parts grow proportionally in an independent fashion, and so that the growth rates are both independent of size and independent from one period to the next. The problem is that, of course, cities are not independent, and their interdependencies indeed are part of the explanation of this common regular mean growth rates over time when they are sharing the same territory. And this observation was coined as early as the 16th century by a specialist of state and advising the popes for governing a state. He wrote a booklet about delle cose della grandezza e bellezza delle città, explaining that the cities were always in competition, and the good governance for them was to be aware of the performance and realization of other cities, and to try to make better in a variety of urban domain, including economic development, relationship with the countryside, quality of life, and beauty of the environment. And he did that not only for the cities in northern Italy of the time, but also about the new colonies in Brazil. So it is interesting to see this complex vision of urban systems so early. and a deep understanding of their dynamics in terms of rivalry, competition, which is still occurring, and that is however difficult to examine quantitatively, because what is an urban valley is so complex, but really operating. Many statistics are missing, starting with urban GDP, which is not usually provided locally, except in China. And many proxies have been are periodically measured and compared in order to provide rankings of city. But how to measure the value of heritage, and those, of course, those assets have values that is evolving over time. So we think that there is a value in the fact that cities are organized together in systems of cities, and there is a lot of returns coming from this networking. And the networks indeed exploit the differences in size and function of cities. I will show that in a moment. There are information remittances in a variety of communication networks that provide returns to cities belonging to a network. We have the opportunity to demonstrate this in the model developed by Clémentine Cotineau about the cities of the former Soviet Union, about 1,000 cities observed on different periods of time and she experimented a simple GBRA growth model that you see in blue. The simulation cannot reach properly the observed population, whereas inserting in the model interactions between cities helped in providing a better prediction. So interactions are actually more than GBRA for explaining the differences in size of cities due to their growth model. So recently, we were interested in scaling your laws because of intervention of physicists from the Santa Fe Institute, and economics used to call the scaling parameter beta in this relationship. It was identified as elasticity, meaning that there are not always relationship of proportionality between the size of an urban entity and its different attributes. But when we met Geoffrey West and his colleagues from the Santa Fe Institute, they just had applied with success their theory regarding scaling to biological species, and they wanted to apply this to urban systems. At first, they would have chosen the growth of firms, but it was too difficult for them to find relevant data for applying their models. So we started this in a European program which was directed by David Lane, Information Society as a Complex System, between 2002 and 2006. And the discovery for physicists was that exponents of their scaling laws, as for instance here between size of Chinese cities and their GDP, could be higher than 1, meaning that the largest cities were performing better than the smallest town. They developed a full work that you probably know about those scaling laws, distinguishing domain of infrastructures mainly, for which you could realize scale economies and having so a beta exponent lower than 1, while services to the population mainly were distributed in a way that was quasi-proportional to the population. And all productions of the city, as patents, GDP, number of inventors, employment in research, were higher than proportional to the population, but as well housing cost and a few noise. They interpreted this in a more or less a static way, as some subsystems in the city realizing optimization and enabling a growth of the sigmoidal type, whereas for individual needs, the growth was simply exponential. This corresponds to our observation, but they suggested that if the exponents were above 1, it could lead to some boom and collapse succession because of finite time singularity of the development, using those equations that, of course, were never possibly applied because too difficult to meet with the figures regarding cities, and this type of growth corresponding to the different beta values. And what was more difficult to accept was their model of urban growth with finite time singularities in shorter and shorter time intervals. But indeed, the examples they show us about New York was absolutely not convincing, and only on one city. The urban trajectories are usually much smoother and continuous. So this physical interpretation of urban scaling laws that would be explained by the accelerating pace of life as a city grow larger was astute and interesting, but not convincing to us, even if it was a big success in terms of mediatic communication. Physicists solve the city. And the problem we discovered when looking at the equations more precisely, indeed, was there is a big difference in the derivation of the equations I show you briefly, and what we can observe in urban systems, because we don't have, obviously, ergodic system as in statistical physics. All cities have not the same probability of getting into the state, the detailed states that are observed in a system of cities. So I will briefly recall the experiments we have done on using harmonized database, which were rather hard to build sometimes. They are not directly given, and you have to consider entities, urban entities that are consistent, that have a consistent and comparable meaning from one country to the next. So we built agglomerations and functional urban areas. And we have experimented with scaling laws, among other models, on more than 20,000 towns and cities in 7 large countries of the world, on 6 continents. So, for instance, different system of cities as France, South Africa, USA, and we have, of course, found the same diversity in the exponents, as our American colleagues, differentiating between urban activities having exponents larger than 1, employment compared to population, whereas other sectors were more equally distributed among city size, and some of them were concentrated in smaller towns. And this was done for China, where we have also a diversity in the exponent, contrasting manufacturing, which is still concentrated in the largest cities, as well as research in blue, whereas education is more evenly distributed regarding city size. So in our theory, we connect the value of exponents with the stage of activities in innovation cycles, innovation waves. And this explains why we find everywhere with exponents larger than 1 type of activities that are currently developing very much: real estate, insurance, financial activities, business, service and consultancy in developed countries, whereas in developing countries like South Africa and China, manufacturing is still among the activities that are overrepresented in the largest cities. And conversely, manufacturing is more concentrated in smaller towns in France and other developed countries. So the theory connects the values of the exponents with the returns provided by the activities in their different stage of their cycle, and it is also a model where activities substitute according to the size of cities within the same system. At the beginning of the cycle, they concentrate in the largest cities, then they diffuse in all the system, and at the end they locate in smaller towns where the costs are much cheaper, but already at that time another cycle has brought new activities, innovation that provide big returns in the largest cities. And we have this schema of a constant flow of innovation that comes throughout the system of cities. When cities capture the innovation, they enter this virtuous circle leading to make them as a metropolis. If they specialize too much in a particular innovation, they may keep for a while a good image, but enter a decline cycle, because this may hamper their ability to adapt to the next innovation. And here you find all cities of the Rust Belt and ghost towns and so on. And of course we are in social activities where overcoming is always possible after a relative collapse. So we have identified successive cycles of innovations that have really specialized a large number of cities in the developed world. And we have actually checked, those observations were earlier than the scaling experiments, but when you look in a short period of 40 years to the relative position of cities in the urban, in the space of their activities represented by the two first factors of a principal component analysis on their economic profile, you observe a remarkable similarities in the change occurring in every city over a 40-year period. This is like the translation inside we've observed quantitatively on the maps of Europe or India. We have this occurring in the change in the inside society of cities, all at the same time, and not only in a small country like France, but in the US, we have been able to observe the same trend into this diffusion, very rapid diffusion and adaptation of cities to the ongoing changes in activities. It is the same in the population, scale of population. And when we map the factor of this principal component analysis, you see how these differences, this major differentiation among cities in terms of activity, but also mean income level, attractiveness, and so on. The first differentiating factor you find correspond to an innovation wave of the century before, which have in which some cities, like around the Great Lakes, have specialized a lot and are still specialized relatively in manufacturing activities, whereas in west and south of the US, you have more service-oriented economy. And if you look at the second differentiation factor, here you have a trace of the diffusion of the innovation waves of the second half of 20th century. And that time, the wave is actually has diffused according to a hierarchical process of innovation diffusion, because you have more specialization in business services, finance, insurance, and real estate in the largest cities of the system, whereas the smallest towns, as you see, have remained relatively specialized, more specialized in more old-fashioned activities. So we link scaling laws with this history of development of innovation cycles within a system of cities. We have put that into multi-agent simulation models. I won't detail this, but with Juste Rimbaud and Eric Denis, we have published that in a recent paper of the journal Sustainability. Sorry, the reference is to below. And so we have coined different co-evolution regimes according to the part of the world. And so we are contrasting this representation of a dynamics where the differences matter and are part of the mechanism of the development of the system. And we are not very satisfied of an explanation which would infer from transversal observation a longitudinal interpretation. If you look at what Louise Bettencourt and Geoffrey West have written in their paper in Nature in 2010, with citations here, they interpret in terms of growth, development of one cities, observations that are made at a given moment between cities of different size. And we think this is questionable because it doesn't correspond to what is actually observed. Since their seminal paper, there has been a huge development in literature. You found 100,000 references in Google Scholar with a paper that have really made a great impression in prominent journals. And there is also a paper on urban scaling of cities in the Netherlands. I'm sure you know it, but centers as Casa in London, and Diego Rybski in Germany have also participated a lot in the development of this, the reflection about scaling laws in urban systems, insisting on the importance of delineating cities properly, and so on. And I will discuss with you about the connotations and interpretations that we may derive with those statistical exercises, because in the social realm, one may think that finding exponents below 1 means efficiency, but does that mean sustainability as well? Perhaps adaptability would be a better goal to follow, because urban evolution is so much more rapid than biological evolution. The innovation waves are coming quicker and quicker, and perhaps rather than trying to be optimal to one criteria, one single target, is not the factor success that you can expect. And the same ambiguity is about evaluating for planning purposes the value of exponents above 1, because of course they are observed for performance as well as for inequalities, conjunction, and we don't know how far we can use this for ensuring better predictions. Indeed, in the world, we have a very different issue for developed countries, where the problem is how to convert a quantitative growth into qualitative improvements in urban life. And in the developing world, still rapid demographic and economic growth raise completely different problem of adaptation. And the convergence in GDPs, urban GDPs, which have a tentative examination here by the United Nations, is very slow and very hectic indeed. We also meet with the pandemic's cognitive dissonances, because many people say, oh, I no longer want to live in too dense urban areas. I want to go to smaller towns to live in the countryside. But cities are still making narratives about their development and in a competitive mood. And so they are conscious of the global scale and valuing imitation and homogenization. So in these systems where we have so many multi-level feedbacks, it is very difficult to make predictions. What we can observe with the section habitat of the United Nations is that whatever the level of development of the country, the Human Development Index is always higher in urban areas than in the total of the country. So there are still, nowadays, much better life conditions in cities than in non-urban part of the territories from the point of view of access to education and to health infrastructure mainly, and better life expectancy as well. So policies for trying to keep this network added value inside cities are be we cannot reduce them to a simple computing exercise. And the change we have now is that our system of cities that have developed apparently without constraints coming from resources, but which are now resenting this lack of available resources for their development, they may use the connections to integrate the bottom of the initiatives from the local authorities to take care of the environmental transition, as well as top-down, as usual, the regulations from the international and national governance. And that's why we have tried to insert model aiming at testing a variety of scenarios to try to contribute to this evaluation of urban policies. Thank you for your attention.
Yeah, thank you very much for this very interesting talk. Really gave a nice overview, and I think there will certainly be questions from the audience. I saw in the chat one already from Jaap. Jaap, can you unmute your microphone and then ask?
Yes, can you hear me now?
Yeah.
Yes.
Okay, well, my question is, you try to use scaling laws defined in terms of formulae, so mathematics. But
Yeah.
I wonder whether that works because the relationships are so complex. So I think, why not try to find the latent or hidden relationships you're looking for using machine learning methods?
Oh, I think in order to use machine learning methods, you need a great amount of data to train the network. And I'm not sure that we have enough data comparable in a large number of cities over long enough period of time to do that now. Perhaps when the amount of big data that are collected with the phone and other sensors will be available, it will be possible to use these methods instead of classical statistical exercise and simulation modeling. But at the moment, I think we lack of relevant data for doing that, unless you know examples of people who tried this already.
Well, I could imagine the data, you don't have the data maybe, but there are data available, and I reckon the big sort of companies like Google and Facebook and so on, they have enough data. If you could make use of those data, you probably will be able to make use of these machine learning methods.
Yes, but there are rather specific data. They are not the data that would describe the urban entities in a comparable way. If, for instance, if you think of Facebook data, you can find similarities when people in Shanghai, Beijing, and Atlanta tells about hospitals, infrastructure, and things like that. But there are many other social features that will not be comparable.
Isn't it that most nations, they have statistical offices, and that if you can collect all the data from the national offices, you might have sufficient data to really use these machine learning methods?
I guess I would like you to try. because we have, for instance, recently with Céline Rosenblatt, we tried to compare cities in the European Union, and we worked before with a group of researchers, and we were able to find some 60 or 80 comparable indicators for cities. And we did not cover all the realm of information we would have liked to. So it's the statistics, by definition, were established by the states, wanting to know about their society, population, and equipment, and they are state-specific most of the time. For instance, for example, in Europe, it is only since less than 10 years that we have a common spatial delineation for urban entities. Before, we had to deal with as many definitions as there are states in the Union.
Okay.
So it is a very long process, but yes, I would welcome this way of trying to find latent. You know, I showed you factor analysis, principal component analysis. It was a way of trying to find latent variables behind the data we had at the moment, and the data came from censuses mainly.
Okay, thank you very much.
Yeah, thank you very much. Any other questions? Well, I have a question, so others can still think. I was a bit intrigued by these different exponents you showed for population growth, population versus also manufacturing and education.
Yeah.
I think there was this picture from the cities in China, I think.
Yeah.
Now, these exponents, they're different, but they're in some way also coupled, right? I mean, they're a network of networks in the city which are connected somehow. So is there any is this hierarchical diffusion of innovation model, is that capable of explaining those different exponents? Yeah, this one, yeah.
Yeah, yes, because it is a hierarchical diffusion. But this is an example of we have to adapt nomenclatures to every culture. And in a developing country, the manufacturing activities which existed in developed countries for 2 centuries, a very long time, there, in the way they are now effective, they are still an innovation, something new, something providing high returns when they are producing. And then in China, manufacturing activities are concentrated still in largest cities.
Okay, yeah.
Is that an answer to your question? Yeah?
Yeah.
And it was the same in South Africa, okay, for which we got data because someone was making a thesis on the South African cities.
Yeah. Okay, thank you. Any other questions from other people? So maybe, I mean, what you have now these models, this Simpop variants of models, right?
Yeah.
Is there any skill assignment to those models if you go to the past? For instance, we call that hindcasts. Have there been any studies to that? What kind of skill they can have in the past?
Indeed, the applications of the Simpop they are kind of retro prediction, yeah, of what we observe when we have statistics. In the case of the Simpop local model, it is purely synthetic data relying on the literature for estimating the relevant parameters that explain how cities emerge and develop, starting from their connection and exchange of information between them, which is considered as an entity which is called innovation and which evolve over time, providing a return on the population from the local resources. And otherwise, we have tested the Simpop model on the cities of former Soviet Union. This was made by Clémentine Coutinho in her PhD thesis in 2014. There was other work with Anne Bretagnol experimenting on Europe and United States over several centuries. Europe, we took data like De Vries, you know, his book on European urbanization. So taking historic data since the Middle Age until 2000. And for the United States, we observed the development of cities from 17th century until today.
Yeah.
But each time we try to have this definition of a city which is not purely local or political. We try to find the consistent geographical entity which is developing both in terms of population and of spatial extension.
But do you have any skill measure of that model? I mean, skill, you know, if so prediction value on a certain lead time, is that type of study done?
Prediction value on?
Well, you know, I mean, weather prediction models, you evaluate them eventually with a certain skill, right? So they do statistically in some way, they do correct. So and in weather models, the skill decreases very quickly if you go beyond 5-6 days or so. I realize these are very different type of models, but you could do sort of model simulations in the past, where you start say well in 1980 or so, and then see how the city will develop over the next 10 years or so, and use those models to see and then evaluate what really happened. I mean, is that possible in this kind of model context, or is that impossible?
No, it is possible. Yeah. Actually, it is what is done.
But what kind of skill measure is then there? I mean, how do you? I mean, you have to have some kind of performance measure. How is that?
The performance, you have several possible measurements. One global, which is the sum of square sum of errors between the predictions of the model and the observations.
Yeah.
And you also can have a look at the variety of the individual trajectories of cities.
Mm-hmm.
In the model and in reality. And sometimes you can rather properly adjust it, and sometimes not. For instance, working on cities of the Soviet Union, there were some trajectories which were impossible to explain if you didn't consider that at a given moment the government decided to develop a very large city on a specific mineral resource in some place, and so the development of the city didn't follow the normal process of the other cities. So, but she developed with colleagues in computer science, she developed a process of building model. She calls it multi-modeling, where you can add different mechanisms successively, or peculiarities of the environment or the policy, like the one I just mentioned, and you can measure the quality of fitness of the simulation in if you add more data, more parameters, or if you change the mechanism for explaining the growth.
Or stochastic effects, right? Like this, what you said, the city sort of set up by the government, which can be stochastic perturbation. Yeah. I saw Jaap had another question. Yeah.
Yes, I unmute myself again.
Yeah.
The question I have is, the idea of the research might be that you would like to suggest to governments to follow a particular policy in order to get a particular aim established or realized. Is that indeed the idea of your research, so that it come up with, whenever you do this or that, then the city might be developing in that direction? And has any government any time followed any of your suggestions?
Indeed, what we have done until now is purely academic, and it is very difficult to try to use the work we have done unless you are governing at a level where your policy may orient the future of a set of cities. I think it is at that level, either the European level or the OECD or Habitat, that our work may help in trying to better take advantage of the synergies between cities that are interconnected. Because if you want to provide an advice to a single city, of course, you will explain that it has to take care of what is happening in the rest of the system. But taking perhaps we can help one city to have a better evaluation of what is its specific value of its local situation within the system. But I think the research we have made is more useful for seeing, trying to explain, don't imitate too narrowly what another city has done because you are not in the same situation, or take a better advantage of what is circulating within the system. I think it is at that level that what we have analyzed would be more useful.
Okay, yeah, that's I think would be very nice if from all the data you have and all the relationships you have derived from that data, you can say, in this particular situation, if your aim is to get, say, higher educated people, whatever the aim is, then take those measures.
Yes, but each time a city is doing something like that, the others do it as well. If it's promising and successful, and imitation is indeed a very strong attitude in the behavior of cities.
Yeah, but that shouldn't be a problem, because in your model, your latent relationships, you include the fact that maybe other cities might also do the same thing.
That's right. Yes, that's right.
Okay, thanks.
Any other questions from the audience? I don't see anything. Okay, well then I want to thank Professor Pumain again for the very nice lecture and for the subsequent discussion. Very much appreciated.
Yes, may I ask myself a question?
Yeah, of course.
What do you think, you, in your group, dealing with complex systems, what do you think about this scaling?
In general, you mean?
Yeah.
Well, you know, I'm not a urban specialist. I'm a climate scientist.
Yeah.
And, we use scaling quite a bit, actually, particularly now in terms of climate variability, or also, for instance, precipitation, right? How that scales with certain, say, time or in space. So scaling is still, I think, very important in many, say, fields.
Yeah.
And of course, on some aspects, you can actually have, of course, a lot more data where you can establish that scaling, for instance, for precipitation also. And for others, it's of course more difficult. If you go to climate variability on the long time scale, like glacial cycles or so, then it becomes much more difficult to apply that type of, say, analysis. But there's still, it's in the climate very important. And for other, I mean, there's a really diversity here of public in the Complex Systems Center. And yeah, we had this lecture series also now to actually, you know, see how that is being applied in very different fields. And so that's why we also, you know, the very diversity now, we see now it in urban, say, applications. And so that's very nice to see.
Yes, very important. Okay.
So we think it's still an important subject, right? Which is really part of the core of complex system science, because it has a specific meaning and how processes organize.
Oh. Okay.
Yeah.
Thank you.
Okay. Well, thank you very much for attending also. And to close up, I would highly recommend our next talk, which will be by Thomas Ficek, which is basically on also related subject in why we behave hierarchically. So he's going to give a talk on December 10. He's also written a book about it on mechanisms of hierarchical behavior. So that's really nice to hear. And so with that, did I forget anything? Oh yeah, I forgot. I just got an email from Robert that the Complexathon kickoff was held last Monday. And so if people are still interested to hear what was being talked about, they can actually look at the Complex Systems Center, and as the meeting was recorded, and you can see what was all discussed. And if you're interested, you can still sort of with a team participate into the challenges. So with that, I will all thank you very much for the attention here and being present, and wish you a nice rest of the day. Bye-bye.
Bye-bye.